Assalamualaikum Tarek, how are you?
Walaikum salam. Fine, thank you. And you?
Good. All right, Tarek. So I believe we were done with binomial expansion the other day, binomial theorem expansion and everything else, right?
Yes, we are.
Because and I believe we did the questions as well. I gave you some harder ones and some easier ones. So
Yes,
today we're going to start off with what you may say,
differentiation.
yes, and it's not entirely hard, but the only issue with differentiation is that when it's paired with its other topics, differentiation itself is not hard. A question which involves just differentiation is very, you can say it's even IGCSE level. All right. Oh, just give me a moment. All right. So differentiation itself is extremely easier to understand and to apply it to the question. When it becomes, when it's coupled with even differentiation in your I would say P1 is very easy. When you get to paper 3, differentiation is very a lot of other topics are included in that differentiation, so it becomes very difficult for students to understand, and that is the case. But your base in differentiation should be accurate enough to, maneuver through that. We're going to start off differentiation. So when we begin with differentiation, I'd ask you, Tarek, what do you feel that, what does it mean generally, without even math and everything? What do you think is the meaning, the literal meaning of differentiation? Hmm? Yes, Tarek. Can you hear me, Tarek?
Yes, I can.
Yes. I'm asking you, Tarek, what do you think differentiation means? What is your idea of differentiation?
Honestly, I can't find the words to describe it.
Okay. But still, any idea at all. Give me an example. Anything at all. Like what
Mm,
comes to your head when I say the word differentiation?
like when we have a function and then we try to find its
Mm, it's what?
its
Yeah,
derivative,
yeah. You're absolutely right.
its derivative.
Yeah, that is excellent. That is it. That it. That is the true, meaning of differentiation. All right. Differentiation is simply, very simply, if I'm putting forth differentiation, it is very simply that we're trying to calculate some, or we're trying to see some change in a quantity when that particular quantity has some sort of relationship with another quantity. So, due to that relationship, if one quantity changes, the other quantity is going to obviously notice some sort of change as well. And differentiation is that in all of its essence. You see the change in one quantity with respect to change in another quantity. Is this clear, Tariq?
Wait, could you repeat it? Could you repeat that again?
Yes. Differentiation is trying to calculate, or it's kind of like the process of, if I say it in very simple and general terms, it's the process of, distinguishing between two things. You're differentiating stuff. On what basis you're trying to differentiate is the change. In math, differentiation is going to be the change that one notices in one quantity with respect to change in another quantity. Is this clear, Tariq? Differentiation itself is simply, very simply putting it forth, change in one quantity. Let's say, any quantity, let's say A, and with respect to change in another quantity. That is the very literal definition of differentiation, regardless of math and everything. We're not focusing on math right now. We obviously know that this sign is delta. This is delta, which obviously, details what this signifies change in any sort of quantity or whatever it is. And more so, A and B are, or they could be any two quantities, or you could say values. Now, how are we trying to do that? We are trying to see what sort of change A is going to experience when there is a change in B. That is what we're trying to see. We're trying to see the change in A with respect to change in B because of the fact that these two are in a relationship with each other. A and B are in a relationship. Therefore, whatever sort of change B undergoes, it's obviously going to have some sort of effect on A as well. All right. One thing that I want to discuss with you is, do you know what are independent and dependent variables?
Yes.
Okay, can you tell me what these are? Let's start off with independent variable. Can you tell me what is an independent variable?
An independent variable is a variable which controls the other variable. It means that if the independent variable changes, the dependable variable changes accordingly.
Hmm. That is absolutely excellent. You're absolutely right. Uh, an independent variable is obviously going to be a variable which can stand on its own, But it obviously, if it undergoes any sort of change, it's going to have the dependent variable also go under some sort of change, because the dependent variable is depending on that variable. Okay. Let's just say that you know, we normally say that your independent variable, oops, and what about the dependent variable, Tariq? What do you reckon? What is that?
Yeah, just like I said, as I mentioned before, the dependent variable is a variable that changes according to the independent variable, meaning that if the independent variable changes, the dependent variable will change accordingly.
Yeah. So it's kind of like the opposite as well. The dependent variable is extremely dependent on the independent variable. Whatever sort of value the independent variable has, or whatever sort of change it undergoes, it's going to have a direct effect on the dependent variable. Okay. This is your independent and dependent variable. When we talk about functions, you've got your inputs and you've got your outputs. Can you tell me, out of your inputs and your outputs, out of them, which is the dependent and which is the independent variable?
The dependent variable is A, maybe I guess, and the independent variable is B because A is reacting to the change according B, right?
Okay, that is perfect. That is absolutely all right. Perfect. But I'm asking about in a function. Forget about differentiation. Forget about this. I'm asking about in a function. Can you tell me which is the dependent and the independent variable? Keeping in mind that in a function, it consists of inputs and outputs. So I'll write this down as well.
I mean, the subject will be the independent variable, but the dependent variable will be in a, in some sort of expression.
Okay, okay. So can we say that, in a function, you have inputs which lead to outputs, right?
Yes,
So out of these, what will be my independent variable?
the input.
The input. Why? Because whatever sort of change the input has, it's going to have an effect on the output. The output is dependent on the input in order to produce some sort of value. So this is your independent variable. And similarly, this is your dependent variable. Okay. Wait, let me write this down. We now know that functions are like this. The independent variable is also your, what you may say, input of a function. Let me try to move this down the road. And inputs of a function are usually inputs of are usually values of x, because the function is usually, f of x and whatever it is. Similarly, as to what we were doing, the dependent variable is going to be the output of functions. Whatever function that you're going to deal with, the dependent variable is your output of function. Now, once we look at it from a differentiating point of view, you said it excellently that if I try to link this with differentiation, it is going to give me change in independent variable. Oh, change in what? Okay, tell me what it should be. Yes, correct. If I'm linking this with differentiation,
Change in independent variable over change in dependent variable.
yes, because it's no sort of like it's going to be of no use to us if you're trying to calculate the change in the independent variable with respect to the change in the dependent variable. Why? Because the independent variable is not going to notice that much of a change due to the independent variable. Always, the dependent variable is going to undergo some sort of, change due to the independent variable. And differentiation is what? You're trying to look at change in a certain quantity or value with respect to change in another value. So the dependent variable is the only variable that changes due to any sort of change in your independent variable. So it's going to be the dependent variable over the independent variable. Is this clear?
Yes.
Okay. All right. Keeping this in mind, this is just differentiation as a whole. We're not talking about graphs, we're not talking about equations, anything at all. This is differentiation with its literal sort of definition that the dependent variable and the independent variable are your inputs and outputs and whatnot. If we were to put this, for example, if I have a function which says, y is equal to x, can you spot the independent and the dependent variables in this, Tariq? Hmm?
The dependent variable is y and the independent variable is x.
The dependent variable is y and the independent variable is x. So if I want to derive this, if I want to derive y is equal to x, can I just write them as change in y over change in x, right? Is this clear then? If I simply want to, showcase any sort of change in y with respect to any sort of change in x, and I want to, simply putting it in very simple terms, I want to, do derivation of them. I can simply write the dependent variable on top of the independent variable and note it and calculate their changes in order to see the overall change in that dependent variable. All right. Now, moving forward, let's look at something different. Can you tell me what is the formula of the gradient, Zalik?
Y2 minus y1 over x2 minus x1.
Okay, so gradient.
Or no, forget it.
Sorry, Zalik.
Never mind.
All right. So y2 minus y1 over x2 minus x1. Technically, what you're trying to do is that you're taking y2 and you're taking y1, and you're trying to calculate the difference in them. If there's any sort of increase, if there's any sort of decrease, right? You're trying to calculate any sort of difference in them.
Yeah, oh yes.
Can I just say that this is change in y over change in x?
Absolutely.
Yes, I can. Because we have just said, just above, I took a random function and I simply said that, in order to derive that random function, I can simply just write, under root O, change in y over change in x. When I calculate the gradient, it comes naturally to me that the formula of the gradient is also doing the same. It is calculating the change in y with respect to change in x. That is what my gradient is saying, doing. So indirectly, can I connect the dots and say that my derivation is equal to what the gradient I've solved? Can I say that? Is this clear?
Yes.
I can say that because why? When I'm deriving a certain equation, it is also leading me to change in y over change in x. When I'm taking the gradient of any sort of equation or whatever it is, I'm getting y change in y over change in x. So simply capping it all off, I can say that the gradient of a function is equal to the differentiation of a function. Right, Darius? Because I have proved it. I have proved it through the literal meaning and the literal definition of differentiation and through the literal formula and the literal definition of gradient. Okay. Now, simply going back up top, differentiation, when you're doing differentiation, you simply write it in a different way than as you would write change. We use, sometimes people call it curly as well, but I like to call it dA over dB. Is this clear? All right, then. And I can simply write it as, I can change everything over here now. I can write it as D for differentiation. Clear? Then obviously I can write it like this over here as well. I can write it like this. How? I can write it as dy upon dx. So finally, the conclusion that I can come to is that the m, or you can say that the gradient. By the way, do not make this mistake. A lot of students do make this mistake. Gradient is denoted by a small m or a lowercase m. Midpoint is denoted by a capital M. Do not confuse the two. Okay, and students do sometimes, even though it's like something which you might be like, oh my god, who can make this type of mistake? But mm, people do. I have checked this type of mistake in students, so be very wary of that. The gradient, I can simply write this as dy on dx. Is this clear, Tarik? Hmm? Tarik?
Wait, wasn't it delta y over delta x?
Yeah, delta y over delta x. I'm
Wait,
I'm just
is
I'm
it
just
is it
yes.
the same? They are not the same.
Why are they not the same? Hmm? I'm telling you that when you do differentiation, instead of writing delta A over delta B, you can also use dA over dB. You have to use this symbol now in order to showcase that you're using differentiation. It's the same thing. I'll put an is equal to sign over here, just as I did over here. And you can write D or you can write delta. It's the same thing over here as well. Dy upon dx, or you can write delta y over delta x. But when you're doing differentiation, you're going to use D. Is this clear?
Okay, yes, clear.
All right, Tarek, is this clear?
Yes.
Okay. Okay. So whatever it is, you can either use D or change in Y. But when you're differentiating, obviously you have to use D. All right. The gradient is dy upon dx, or you can say delta y over dx, or delta y over delta x. It's the same thing. But because we are doing differentiation, we will show this is the symbol of differentiation. Okay. This is the symbol of differentiation, which tells the examiner that you're taking derivatives now. When we do integration, you will also see the integral sign as well. That is going to show the examiner that we're doing integration. Otherwise, we're just writing down functions. So how will the examiner differentiate himself that what are we doing? All right. So, so now if we try to, okay. Tariq, have you written this down? Is this done? Any questions regarding this?
Done, no questions.
All right. We now know that the gradient is equal to, the derivative which is equal to dy upon dx. We now know that. We also know that the gradient of a straight line is always what? Constant. Okay. The gradient, if we're talking about gradient, constant for a straight line or constant for a linear equation. You can even say the constant for a linear equation. Non-uniform for non-linear equations. Now, Tariq, the gradient is constant for a linear equation. So we can just easily, you know, derive the linear equation and we're going to get one gradient. But for non-linear equations, the gradient is non-uniform. So obviously the gradient is changing at each and every point. Now, usually what we would have done is that we would have taken a tangent. But using the tangent is a bit impractical and it's a bit foolish as well. Because if you want to find the gradient at multiple points, you're going to have to draw multiple tangents, which is not feasible at all. Because the tangents and on top of that, the tangent is not highly accurate because obviously human error can occur because you're drawing the tangent. So level of accuracy of drawing a tangent is lower. So we can obviously use differentiation, but the derivative or the gradient of a nonlinear equation is not going to be constant. So when we use differentiation, or you can say that differentiation of a nonlinear equation gives us something that is called a gradient function. Okay. Now, what is a gradient function? Tariq, what do you think is a gradient function?
Function that's used to find the gradient.
Yes, absolutely right. A function that is used to find the gradient. Now, how does it do that? A function itself is something that when you put in inputs, it's going to give you an output. So, if I'm using a gradient function, if I'm simply using a gradient function, it is going to give me what? inputs to outputs. But because it's a gradient function, your inputs are going to be values of x, and your outputs are going to be gradient or gradients at those x coordinates. Is this clear? So differentiation of a nonlinear equation is going to help you to find the gradient function. The gradient function is, by all definition, it's a function itself. So it's going to have some particular inputs which are going to lead to some outputs. The inputs are going to be values of, or you can say, values or coordinates of x. All right, because it's a linear equation. Oh, a non-linear equation. So, and the output is going to become gradients at those x coordinate. Why do I have written coordination? Oh, coordinates. Is this clear, Tariq? Any question up to this point, Tariq?
No question.
Good. Okay, now Tariq, give me an example of a non-linear equation.
X squared plus 5x.
Sorry. Could you
X squared plus 5x
x squared plus 5x
plus 6.
plus x
Yes, plus 6.
is equal to y? You know, I can put it is equal to y. Now, if I want to find the gradient, okay, so the question says find the gradient at x is equal to 1. All right, that is what your question is. I know that my gradient is equal to my derivation. My gradient of whatever my function is, whether it's a function in y, x, or whatever it is equal to my differentiation. This is the information that I already have. The box symmetrical then doesn't look like it.
Come again?
I was just asking if the box I was making was symmetrical or not. Now it is. Okay.
No,
I
rectangle
know.
is symmetrical.
Sorry.
The rectangle is symmetrical.
Yeah. Now it is. So now I know that in order to find the gradient, I just need to derive. My equation says y is equal to x squared plus 5x plus 6. I now know that this is going to be the case. So in order to find the gradient, I need to do dy upon dx. Now, how do I do that? Simply write down the equation again. Oops, right. Bit crowded here. X plus 5x plus 6. Differentiation is what? Change in y with respect to change in x. So we're trying to calculate what sort of change y is going to receive when you change x. So technically, we in the equation itself, we're looking for change in the independent variable. We are looking for change in x. Okay. How do you quantify change in x? Power goes to the front, multiply, and 1 minus from the power. Same over here again. What is the power of x when it's 5x, Tariq?
1.
1. Power goes to the front, multiply, 1 minus from the power. All right. Tariq, what is the power of x over here? When 6,
0.
0. Why? Because x raised to the power 0 is existing over here. Because x raised to the power 0 is 1. Power goes to the front, 0. 1 minus from the power. Now a bit of search. If x has a bit of, sorry, indices, sorry. If x raised to the power 0, the answer is 1. If x raised to the power 1, the answer is x. All right. This is simply just what you need to know. No rocket science to it. What is the new power over here, Tariq? And okay, at every place, what is the new power? It doesn't really matter over here because it's going to become 0. But
X, x squared, 0, and -1.
okay, it's going to be
Wait,
then
wait, the last term will be 0, right? Because it will be multiplied by 0.
yes, simple. So it's going to be, oh, this is going to be 1 minus 1.
Yes, but
It's
it will
going to
be
be 0. This is 1. Okay, yes, you're absolutely right, Tariq. Right now, if I write it down, I'm going to write it as dy upon dx. Now, writing it down, 2 raised 2 multiplied by x, 2x, raised to the power of 1. You can write 1 or you cannot write 1, clearly up to you. Plus 1 multiplied by 5 gives you 5. X, what is the new power of x? X raised to the power 1, which makes 1. So you're going to leave it as 5. And lastly, 0 multiplied by 0, or 0 multiplied by x, and 0 multiplied by 6 is just going to give you the answer of 0. So your derivative is going to turn out to be 2x plus 5. Is this clear?
yes.
Now, Tariq, I told you that this is equal to the gradient, but this is a function in and of itself. So can I just simply say that this is my gradient function?
Yes.
Because it's a function as well, and I'm saying that it is the gradient. So obviously this is the gradient function. And what was the gradient function's advantage? That the gradient function was going to be helping us to do what? The gradient function. Yes,
Find the gradient
yes. How to find the gradient?
by
Inputs are
substituting
mhm,
the value of x.
yes, at different points, whatever the point that the question wants, and the output is going to be the gradient. So what is the question? The question says find x is equal to 1. So it's going to be equal to, oh, just give me a moment, Tariq. I have to take a call. Just a moment. All right, Tariq, apologies about that. Now, You need to find m at x is equal to 1. You need to find m is equal to at x is equal to 1. And this is by far your gradient function. So if I plug in the inputs of the x coordinates, it's going to give me an output of the gradient. So simply, I'm going to put at x is equal to 1 into my gradient function. So Tariq, what is going to happen now? It's going to give me m is equal to the dy upon dx, which is equal to 2. So the answer is going to be what, 7? Now you can even ditch the dy upon dx and simply write m is equal to 7. And that will be your answer. Is this clear then?
Yes.
All right. All right. Clear? Have you noted this down then?
Yes.
Okay. Now, Tariq, the gradients for a function. So the gradient for a non-linear equation is going to help you find the gradient. What am I saying? The derivation of a non-linear function is going to help you find the gradient. Also, what's going to happen? Now, this is not the only application of your gradient. You are going to have what? For example, this is an equation. Oh, this is a graph. Let's just say that I draw this. I don't know why my graphs are always weird, but it looks okay. I think so. All right. Okay. Now, what's going to happen is that the gradient that we're trying to find is, irrespective of the fact of what equation we have, we're just trying to find the gradient, and it's very easy. You can use this process again and again in order to find the gradient. But can you tell me, Tariq, what is the gradient at this point?
0.
Why?
Because when we draw a tangent, the tangent will be parallel to the x-axis, which when we use gradient formulas, we know that when two lines are parallel in a graph, they have the same gradient. And the x-axis has a gradient of 0. So when we draw a tangent in the highest point here, we'll find out that the tangent is parallel to the x-axis, hence has a gradient of 0.
Yes. Could not have said it better myself. Excellent. So your tangent is going to have m is equal to 0. All right. Same is the case over here. So this is your, and what is this point called?
Turning points.
Yes. So this is known as
Maximum point.
Yes. Okay. So this is known as your turning point. In most of the questions, the word that the examiner really loves to use is stationary point. And the word that I love to use is the minimum or the maximum. Is this clear, Dani?
Yes.
Okay. We now know for a fact that if you draw a tangent at the minimum or the maximum point, it is always going to be the gradient through that tangent is always going to, get you the value as equal to 0. All right. First and foremost, and by the way, y is equal to ax squared plus bx plus c. Okay, that is the general form of a quadratic curve. And when a is a positive number, you get this graph. Oh, when a is a negative number, sorry, you get this graph. And when a is a positive number, you get this graph. All right, upward opening and downward opening. We now know that at the turning point, at the stationary point, or the minimum or maximum point, one thing is for sure: gradient is equal to 0. Right? But we also know that the gradient is equal to the differentiation. Gradient is equal to dy upon dx. So, therefore, does it mean that at the stationary point or the turning point or the minimum or maximum point, dy over dx is also equal to 0? Right, Tal?
Yes.
Yes, it's just as simple as that. So, if I'm using the same example, okay, no, let's use a different one. Okay, Tariq, give me another equation.
Non-linear.
Yeah, non-linear, obvious. Tariq, how can a linear equation have a turning point? Come on.
All right. 3x squared minus 7x plus 4.
Minus 7x plus 4 is equal to y. And they say to find the minimum maximum point. I know that at the stationary point or at the minimum or maximum point, first thing that I know is that m is equal to dy upon dx, which is equal to 0 at the minimum or the maximum point. Okay, this is what I already know. Okay. I also know how to find the gradient. How do I find the gradient on this? So it's going to be simply what y is equal to 3x squared minus 7x plus 4 dy upon dx is going to be equal to what? Ax whole square. What was it? Minus 7x. Minus 7x plus 4. 2. Power to the front multiplies 1 minus from the power. 1 power over here. Power to the front multiplies 1 minus from the power. Power to the front multiplies 1 minus from the power. So if I were to find the value of the gradient, which is equal to the derivative, it is going to give me what? 2 times 3 is going to be equal to what? That 6x raised to the power 1. I can write it as there. Minus 7, because x raised to the power 0 is equal to 1. And that is 0. So one point that you can note is gradient of, oh, sorry, not gradient, derivative of a constant term is always 0. All right. So derivative of a constant term is always 0. Okay. Also, can you explain to me why, Tariq? Like it's not included in your syllabus, but just for like the sake of learning. Why do you think the derivative of a constant term is 0?
I don't know, maybe because there is no variable.
No, not really. Tariq, okay, what is the definition of differentiation?
The change in
Okay, I'll stop you right here. Change. Can a constant term change?
no.
Therefore, the derivative is 0. Because the differentiation is always going to be to notice some sort of change. Therefore, a constant term never changes. So we just put it, the derivative is not possible for a constant term. So we say that it's 0. All right. We found the derivative. Now I know for sure that I need to find the minimum, maximum, and the stationary point, whatever it is. So at minimum, maximum point, m is equal to 0. So if m is equal to 0, therefore, can I write it as dy upon dx is equal to 6x minus 7. Further, can I write it as 0 is equal to 6x minus 7?
Yes.
Yeah. Okay, through this, Tariq, can I find the value of y? Oh, the value of x.
Yes.
X is what, 6 over 7?
7/6.
Apology, 7 over 6. Positive. Okay, now this is what? This x is the x coordinate of the minimum, maximum point. Okay, this x coordinate is the coordinate, this is the value of x is the x coordinate of the minimum, maximum point. Now, what's going to happen is that in order to find the minimum, maximum point or the stationary point, I need the y coordinate as well, the corresponding y coordinate. So do not make this mistake. This is another mistake that students do. They forget focus, or I don't know what happened. They put the x value back into the derivative. That is not going to give you anything. That is just going to give you what? The gradient at that point. We don't even need the gradient over here. What we want is the minimum or maximum point. And in order to find the minimum or the maximum point, we need the value of y. And how do we get the value of y? When we put the value of x back into the original equation. All right. So put x in the original equation. Do not make this mistake. I have seen students, just because they're in a hurry, or, maybe it's a careless mistake or whatnot, but they do try to make this mistake that they try to put the gradient, in a hurry. They put it back into the gradient. So make sure you are not doing that. Put x in the original equation. Tariq, could you repeat what the original equation was? Hmm? It was 3x
Six
squared
x
minus.
6x squared minus 7x plus
Tariq, it was 3x
4
squared. Come on.
3x squared.
Yeah. You told me the equation. This was the
Yes,
equation.
yes, it was 3x squared.
Minus 7x plus 4. Was it plus 4? Okay. X is also equal to 6 by 7. Putting x as 6 by 7, I'm going to get y is equal to 3 times 6 over 7 whole squared minus 7. Was it 7 over 6 or 6 over 6? Oh, come on. Tariq,
7 over 6.
you're also sleeping. 7 over 6. Okay, Tariq, tell me the value of y. Calculate this.
My calculator got it in decimals, and it is something like negative 0.083.
It's a negative answer.
Yes.
0.083. Okay, tell me what is the answer in decimal over here as well. 7 over 6.
1.167.
1.167. Okay. Now this is the y coordinate of the stationary point. So your minimum maximum point, whatever it is, we don't know for sure. It is equal to 1.67 or negative. That is your. Is this clear, Tariq? Any questions regarding this, Tariq?
It's clear. No questions at all.
That is excellent. Now, I'm afraid we've run short of time, but next up, what we're going to do is that we're going to see how to find. Now, we have found the minimum maximum point, but we don't know whether it's the minimum or the maximum. So the next thing that we're going to learn, and it's probably going to be on Thursday, that it's
Wait, isn't it a quadratic function?
what? Sorry, could you repeat that?
W- Wasn't it a quadratic equation?
Yeah, it is a quadratic equation.
So there's only one turning point, and when A is positive, so it's a minimum point.
Okay. But for example, let's just say that you don't have this.
Yeah, it's cube.
Yeah. Okay. If whether it's I told you, I've never, if you can, clearly see throughout the duration of this class, I've not ever said quadratic equation. I've always said non-linear. because
Yes, I
quadratic
know.
equations are not the only. I could have just said quadratic equations because you were giving me quadratic equations. The reason why I was choosing my words to be non-linear is because we're going to do cubic examples. We're going to do, exponential equations as well, reciprocal equations. So then obviously the ideology is going to remain the same. You are going to find the derivative the same way. The only difference is going to be in the nature of the stationary point, in the, how many turning points there are going to be, and stuff of that sort. Is this clear? So we're going
Yes,
to learn how to find the minimum or or even Tariq, if it's a like, quadratic equation, but they don't give you the what you may say the equation. They give you the gradient function, and they tell you to find the quadratic. Oh, they tell you to find the turning point, and they also tell you to find the nature of the turning point, and they have not given you the equation. So obviously, then you are going to do what? You're going to find the nature of the stationary point, and that is what we're going to do on Thursday. All right. Any questions regarding this?
no.
No. Then that makes me happy. So happy weekend. Love this.